Okay, so how's our bandwidth going? Doing alright? Shows 0 viewers in red. Well, duh. Okay. So... Alright, let me get to the whiteboard. Play my music. I get 9 views already. Interesting. Alright. How's it doing? Oof. And I'm dropping a ton face of frames. Okay. So yeah, it is pretty stressed. But for the purposes of what I want to do for this stream is just do tutoring. It's not going to require super smooth orientation. So, okay, so that I'm going to have to note that. Huh, I got 1 viewer already? Interesting. Still setting up everything right now. Do I have 1 viewer? Do. Hmm. Alright. Just letting people know that I'm actually online. Let's see. Alright. Well, I guess everything is working, well, subpar. Percentage of depth drop frame, 64%. Oh, lord. Well, noted. Okay. And the program I'm using right here, you can probably see on the top right here, is called Smart Thinking. I'm just using it as a form of, so I've just gotten familiar with it from my current job. I can even do equations. For example, what would be a good equation to work with? Let's say kinematic. Let's see. Delta x. Now that would equal initial velocity times time plus, make a fraction, 1/2. Acceleration t squared. That'd be a physics equation we could work with. Interesting. Oh, just me. I'm the only one viewer. That makes sense. What? No recommended changes? I'm dropping 60% frames. He says excellent. Twitch, what are you doing? Well, that's alright. Oh, wait, no, the drop frames is because of... Okay. Twitch can't detect that. Noted. And if you hear a faint amount of metal being played, I have my headphones on from my phone playing music. Do 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 do. I'll pause that so well, actually, does that hurt? There's a massive delay, isn't there? Oh wait, no. Let's see. Move my mouse. Okay, 5-6 seconds of lag. It's not too bad. A bit of a delay, that's fine. Alright. I just have 9 views so far. That works for me. Huh. Okay, I like how that's displayed on Facebook. Okay, cool. But yeah, if I want to do streaming my gameplay. Wait a minute. So I guess my tutoring is actually would be still be plausible using this method. Oh, maybe I'm getting a little too loud. I'm looking at the mixer right now. My voice almost got to the red area. I don't want to burst anyone's eardrums. Let's see how my organic chemistry is. I'm trying to think. Let's see. Capture hydrogen, bromine. I can change that. Haha. Okay, let's display this plus sign right here. And we need to show something called a hydride shift. That's a little too close. There we go. That'll work. And from there, bromine will either attack, And here we would get an enantiomer effect because bromine can actually attack from the bottom or the top. Well, I don't know what just happened there. Let's try it again. Alright. Also keeping an eye on how hot my laptop is. I'm running this on an 8-year-old laptop. What am I doing? That's not quite it. Alright. I have... Oh! This would not be chiral. Derp. Because there's 2 methyl groups that are attached here. So... let's move that. Have bromine. Alright. Also told my buddies I'm actually doing this. I want to check out his work. Everyone's actually getting productive. I love it. I actually kind of like this whiteboard program. This is kind of nice, though. Like, whoever wants to read it, I mean, they're more than welcome. Actually, if they want to ask questions or such, they're more than welcome too, because, well, that's why I'm online right now. Just whoever wants to ask questions. Even though I am testing this, it's just, hey, that includes the test right there too. I've been playing an awful lot of Animal Crossing. Just looking at my Switch right next to me. Well, at the very least, my laptop stock mic is actually not bad. I'm just tapping my headphones and it can pick that up too. And I do have my fan running in the background because, well, my room gets hot. Unfortunately. Number of dropped frames over 20,000. Okay. Oh, that's just hilarious. And my icon that I actually have, that says "We love organic chemistry." Let's see, that's from helping out helping out someone. There's a story. There's a long story with that, but let's not get into that. Many of my close friends know. Whew. Okie dokie. How's everyone doing? All one viewer, which is me. That's all good. Who else is online? Not only am I just testing my tutoring, I'm also testing this stream in general. Because honestly, I can play video games, stream my video games, which I'm kind of thinking about doing greatly because playing video games by myself just doesn't feel like as great as it used to. It still feels great, but it's missing something. I think a lot of people that have actually switched to streaming have the same experience. They just want to get to streaming their games so they actually talk to people online, which is really neat. Me, I want to actually do a dual methodology of it, where I can tutor on here, and I want to actually be able to master other whiteboard programs besides this one, because I'm not too sure how long I'll have access to said whiteboard here. It's a really good one. But also another reason why I'm thinking about others is you might have noticed that it's only in red. I can only draw in red in this whiteboard. It's rather limiting, and yeah, it's okay. Okie dokie. Well, at least the proof of concept actually holds. It's being broadcast, and actually I can see it just clear as day. Yep. Streams. Actually, Huh, even with that many drop frames, it still looks pretty decent. Okay. Good. Okay. Yeah, future purchases of setup, like building my setup, try to get a portable monitor, secondary monitor for for the laptop, so that I can have focus the whiteboard on one screen and have all the streaming stuff on another. It's kind of weird trying to do it on one screen, but I made it work, because the whiteboard only takes maybe 80% of the screen and chat the other 20%. Well, 15% for chat and 5% for Twitch stats. Looks like I have somebody else on here. Maybe. So my numbers are showing 2 viewers now, so supposedly, if you want to ask a question, feel free to type it in chat. Let me do a stoichiometry question real quick. Let's say metabolism of sugar, well, or the net equation for it, well, net equation for glucose, that is. Ah, yes. I need to adjust this. Let's see. Actually, I'll actually explain how to balance the equation too, because why not? Alright, let's put this right here for now. And let's say, for this question, if 250.0 grams of glucose with excess oxygen, how much is produced in the following reaction. But first, we need to balance out this equation. Okay, so our first mission, to balance out our equations here. So I have 6 carbons here, but only 1 here. To balance out the carbons, I'm going to place a 6 in front of the C on the CO2. And in turn, to balance out the hydrogens, 12 hydrogen on the left, I have 2 hydrogen on the right, but I have to multiply it by 6 in order to obtain 12 hydrogen. Now for oxygen, I would have 6 times 2, or 12, plus 6 times 1, or 6. 12 plus 6 gets me 18 oxygen on the right. On the left, I have 6 here, so it means I need 6 more, or 12 more oxygens for O2. Kind of tilts up my hand there. It's actually 6 is the coefficient there. So this would be balanced. Now to calculate this. To do that, we're going to use something called stoichiometry. So I have 250 grams of glucose. To be technical with my description. That's why I'm using this program, to really just organize all the data well. So we're going to use the conversion factor. So now I have to figure out molar mass of glucose. So for 1 mole of glucose, be an unknown number of grams, which I will calculate in a few moments. I really needed to get my typing skill a little bit sharper. Well, that's alright. Now, to get the molar mass of glucose, to be 6 times 12.01 plus 12 times 1.008 plus 6 times 16.00. Now these values I obtain essentially from a periodic table of elements. Should get you 180.156 grams per mole. So go back here, we'll change our question mark here to 180.156. Now, next, we're converting moles of glucose to moles of water, as we want to know how many grams of water are produced. From the equation, there's 1 mole, or the 1 coefficient, be 1 mole of glucose here, for 6 moles of H2O here. So I would have 6 moles of H2O. Let's see, for mole of H2O, the molar mass of water So we continue the same calculation here. For water, it would be 2 times 1.008 plus 16.00 for oxygen, get you 18.016. Alright, with that set up, why don't we calculate this out to see how much grams of water we will obtain. So 250 divided by 180.156 times 6 times 18.016 gets me, that's a nice number, 150.0. Okay, we're using 4 sig figs because of the 2250.0. The 150 grams of water. Ooh, let's move this so it's out of the way of that arrow. And I just have a calculator and periodic table on, well, the calculator on the side. The periodic table, I've remembered a good number of values, at least the common elements. Just faster that way. Let's see, what else can I do that's not too vigorous within math, chem, and physics? I could always draw the unit circle. Let's see, do I have enough room? I do have enough room. At least on this page. Let's see. Let's try that again. Yeah, unit circle isn't really that big of a thing, but let's just talk about it. Well, actually, it is a big thing. It's just that depends on your preference of how to memorize these values for trig identities or trig values. Yeah, that's the limitation of this. I'm going to show you something else. My preferred method of memorizing or analyzing trig values be use of the two identity triangles, the 30, 60, 90, and the 45, 45, 90 triangle. Not drawn to scale, of course. That was a horrible triangle. Let's see. Let's see. The square root and the square root of 2 will be right there. $45, $45, $90 triangle. $360, $90 triangle. Trug angle. Alright, so square root. And you might be wondering how I'm actually able to work this program. There's something called LaTeX that actually uses mathematical formulas notation. Wait, no, that's not radical 3. That's radical 3. It's been a minute. It's not only for students' practice, it's also for my practice. Let's see. What do I want to do for my integrals? Let's say 4x cubed plus 6x squared minus a fraction 7/3, and this would be, actually, how about something interesting? X squared on the bottom. Okay, that's looking a little small there, so I'm going to add this command, which for this program lets it display a lot better. Like, see it's larger. Okay, why don't I do this, integrate this. Alright. So, now for integrals, it's actually, we need to change that x squared that's on the bottom there to the top. Let's see. Alright, so I'll have x to the power of -2. And to do the integral, so for x cubed, x cubed becomes x to the 4th, and we'll divide by 4. Because you have to divide by the new exponent, which will increment by 1. So for this one, you have 6, and it increases to a 3. So the x to the power of 3 minus, right, we have a fraction, we have 7, then on the bottom 3 times, so now in the negative power, it increments upward by 1, so we add 1 to negative 2, get negative 1 as the new exponent. We times x to the power of negative 1, and we can't forget our cookie, our constant value, but I call it cookie. It helps you remember. So our answer here would be x to the 4th plus 6 over 3 gets you 2, so that would be 2x to the power of 3. Then we have a plus. This would be still in a fraction form of 7 of 3x, then plus our constant c. Ah, there it is. Keep forgetting how many lines I get to display at once. And that's an indefinite integral problem. What else can I add here? Let's see. Could talk about ooh. What? Oh, there we go. Strange, there was no indication that I actually broke the stream or disconnected. That's odd. Alright. What else are we doing? Oh. I think I know where the second viewer is. Is it me as well? So all I had to do is just so I can run the stream on another window. Being very careful with my laptop, of course. Okay, that's displayed there, displayed there, displayed there. So, that's working at that end. Ah, whoa. Went down to one viewer. I think Twitch got confused maybe. Or someone was just bored and just wanted to see what I was doing, but didn't ask any questions. Which is fine too. Alright, what else to do? Uptime, 51 minutes. And it seems like the computer's doing just fine with it. A lot of draw frames. But that's probably more my connection, not necessarily the laptop. Oh, I can put a... Okay. I did do the calculus problem correctly, right? Because it's been a minute. I did a calculus problem. Oh, the notation. I see. Right. I also need better lighting in my room. I can barely even see my keyboard now. Ooh. LED lit keyboard. Ah, that sounds good. I'll give it a couple of hours. Maybe an hour or two on this thing. It's probably a strange time right now because it's 11 p.m. over at East Coast. Ah. Wait, what just happened? Oh. Cool. Oh, it doesn't let me do Wow, why don't you have enter? In the Snapchat. Reconnection successful. Oh, okay. Oh, so that's where it shows when it disconnects. Goodness. Ouch. That sounds good. Okay, so all social media has now been updated with my Twitch link. But yeah, I think I'm gonna need a new router because it's struggling to keep up with this. What else do I want to work on? We did a little bit of OChem, GenChem, Trig, Calc, Gas Law. Let's see, what's an interesting thing? Oh yeah, activity series. Now, the activity series we have ease of oxidation. And ease of oxidation more readily available to give one of its electrons away. Now, those that actually would give out their electrons would be the metals within the periodic table. Alkali metals tend to be very high on this list. And by the way, this list for activity series is it's very rough. They're kind of mixed layer-wise. It's just to give you a bit of an idea as to what it looks like. Ladder transition. Then you have the heavier transition metals. Okay, maybe an explanation on this before I continue on with that. There are other levels to continue on with that. But let's draw a periodic table real quick, so you guys have an idea what the heck I'm talking about when I'm saying alkali metals and whatnot. You see a little, and you might have noticed on periodic tables, there's a little staircase right here. Again, not drawn to scale because I'm trying to do this by mouse. The thing is about this, all these groups right here, underneath the staircase and underneath hydrogen, all these are metals. On the staircase are metalloids, and above the staircase are non-metals. And I forgot helium's block. Right, not this. Yeah, right there is fine. It's meant for this purposes of just generalization, so I'm not going to worry too much about accuracy. These would be the transition metals right here, and this area right here will still be transition metals, but they're more inner transition metals. Now, these two groups right here, so this one on the left, these guys are alkali metals like sodium, lithium, potassium, which, by the way, are very reactive with water. These are the alkaline earth metals. And these are non-metals. And H. H and helium are non-metals. If you're just wondering about that, I want to be technical. Alright, before I go any more detail in the periodic table, I want to actually complete this. At this point, there is hydrogen would actually be a governing factor. It's really low on this series, but its importance is after hydrogen, you get copper, silver, I think mercury is next after that, platinum, and last would be gold. Now you might have noticed about these being jewelry metals and mercury on the bottom. That's how I would remember. How I remember them. And in fact, what hydrogen means is acids would, well, depending on how strong the acid is, most acids would eat any metal that's above it, whereas anything below it, like copper, silver, like jewelry metals, don't break them down as well. And the reasoning for that, I don't really have the full answer for that, but my current knowledge, because I have only done undergraduate chemistry, because I think that answer is in graduate chemistry, PhD chemistry. Now I noticed with copper, silver, and gold, there are electron configurations. Their electron configuration actually has one s electron, not two, where most transition metals have. It's basically because one of the s electrons will jump to a d subshell for stability. And that's a common theme within any and all chemistry courses. Nature likes to be in its lowest energy state. Anything energetic, it readily gets rid of that extra energy, one way or another. It wants the lowest energy to be stable. And you get into that deeper and deeper as you go into chemistry. There's a plethora of examples for that. Anyway, you might have noticed a little line on here within most periodic tables and two rows underneath. These two are actually within that little thin line there. The periodic table actually looks something like this, but we're fully expanded. Oof, I need to draw better. So this area, that's S, F, D, and P as our subshells. And subshells go into the theme of electron configuration. All right. Yeah, this is getting weird because now, because I was actually maybe, well, actually my expectations were I was probably gonna get nobody to come into the channel. Well, that's okay, but that's why we're testing here. Though, another thing is trying to come up with ideas or questions to answer, but with no questions being asked. Not quite the, well, effective tutoring session, if you will. This is hardly a tutoring session, it's just more, again, a test method. Let's see. Let's see. Nah. I was thinking about opening another page, but I might just close it early because I think I've done enough about... Why did my Twitch stat jump like 5 minutes? This was weird. It was sweet of Quinn to give me a heart for that. Yeah. I'll probably try to do a couple more streams, maybe during the weekend, because it is finals week. Not sure as to if students will come out from the woodwork asking a blaze amount of questions, or they're probably just sequestered to their own devices. Either way, this seems to be a good test run. Really good test run. Just now I know exactly what I need to actually improve the setup, but it still can function. It can function. That's the more important thing for me, is I can actually do it. So I have an additional option for my students if they need my tutoring. Which these past 2-3 weeks I actually had a massive surge of tutoring, but not in person. I've actually been tutoring people via text message, phone call, and a couple via YouTube video. Not necessarily on stream here, which is another option I'm considering, and actually this is a viable option, because I can always just have the student call me and we can just discuss it, and I just have them watch my handwriting from this. Well, either this or maybe a recording from my phone. More likely my phone. Well, would it work with my phone? Because I would have to be able to do a phone call and stream at the same time. Another thing to test later on. Because, well, I don't want to stress any singular device too hard that I have. And I want them to last. If you guys are curious about if you're watching this VOD this long, and you can probably tell that I'm a gamer, which it should be pretty evident. Though, I do watch a good amount of anime, which I haven't really watched recently. I might binge watch Yu Yu Hakusho. That sounds pretty amazing right now. But I told myself I want to actually have at least hour and a half of testing for this to see how it can run, if my laptop can actually handle it. And it seems to be doing just fine. Granted, I'm pretty sure people will be hearing my fan in the background. Well, maybe not as much, because I actually... what software I'm using actually allows me to change the auto mixer to scale down the fan's effect, at least, or at least hypothetically. I haven't really listened to this broadcast, which is a little foolish, but I'm listening to music while I'm waiting for students to show up, so I don't want to sit in silence, and I don't want to put or place any music that's with this broadcast. Don't want to be VOD muted. Not mooted. Muted. Moot. That's a different word. Another thing about me, I could slip of the tongue pretty often, which hence why I want to actually stream my gameplay and talk to people, because I know I'm going to say some wacky stuff that's going to make people laugh. Hopefully. Or at least... yeah, we'll see. Another thing to test. Been a bit successful. Granted, haven't helped a single student on here, but at least I actually am providing something here. Also, I think people can actually whisper to me and text commands to me while the stream is down. That'll give me an idea as to how many people would actually be willing. Though, might have to go into... might have to look into more avenues. What else do I want to actually practice? There were a few questions that I actually helped out some students with that involved... well, there's a complex one for Chem 122 I had to help out the student with earlier. What was the problem? The problem asks, calculate the concentrations for all of the aqueous species if 456 milligrams of calcium fluoride is dissolved in 250 milliliters of water. For hydrofluoric acid, HF, Ka is equal to 6.6 times 10 to the negative fourth. You are to find the concentrations of calcium, fluoride, hydrofluoric acid, hydroxide, and hydronium. Now, the interesting thing about this problem, and why the student actually was so... well, he actually presented it to me because he didn't know how to really work it out, Because there was a lot of hidden things within the problem. In fact, actually, why don't I actually show this problem? I'll type it. This is a really good problem. Solution. And I'm also ad-libbing a little bit within the word problem so I don't cause plagiarism. So I don't want that. Actually, one thing that I actually realized, and when I actually am an author, the thing about copyright, it's really interesting. Would word problems if textbooks actually be copyrightable? Well, I have an argument for that. I'd say depends. It actually greatly depends on the problem itself. What I mean by that, let me finish off typing this one. Whew. Now it's getting a little bit hot again. And as for this, basically this is the problem here. Now, there's actually missing information that the student had to look up. One, we had to look up the KSP for calcium fluoride. Alright. Okay, so for calcium fluoride, calcium fluoride, you get calcium, fluoride, 2 fluorides. Okay, so what is happening here, we're actually going to be labeling off. It won't allow me to actually show that, huh? That's fine. Alright, so This is the first equation we have to work with. Now this is in Chem 122, Gen Chem 2, or the second half of the second course of the first year of chemistry. And it's a chemistry that requires extensive mathematical knowledge. Well, not maybe necessarily just extensive. There's a lot of algebra within it. So the initial values to work with would be the following. And the change, I'll have a plus x for calcium and plus 2x for the fluoride. Now, those of you that just are probably thinking, well, maybe chemistry may not be for me if you actually go through this problem. Well, this problem is more of a very high caliber question. And usually students won't really run into, well, they might run into a problem like this, maybe once in a while. And more specifically, towards our homework. So KSP is going to equal the concentrations of calcium ion, 2 plus, then fluoride ion. Now the fluoride ion is squared because of the coefficient 2 it has. Now you see me type in display style just to make it look a little bit better. Well, attempting to make it look a little better. Alright, so KSP equals, and if we plug in our values of x and 2x to the power of 2, you may have noticed get 4x cubed. So, and then from there, ooh, I don't know how to really enter in a, let's see, what templates do I have here? Nope, none that I need. Alright, so x, if we were to solve for x algebraically here, actually I have an idea. Divide both sides by 4, that'll give me a fraction of 1 over 4. That should be a 1, not a 2. Yeah, note to self for setup. Buy a lit keyboard. That SP is so small. Anyway. I don't know the command for variable root. Well, maybe cube root? I wonder if that is a thing. Nope, no it's not. I'm not going to attempt it. So instead, what I'm going to do, so we have our fraction here. And my sweat is causing my headphones to drop from my head. I'm just going to switch to earbuds. There we go. Yep, I definitely need to get a better setup. I'm going to be streaming, or at least providing that. Now, if I don't know the command of the root, but I can do this to the power of 1/3. So from there, instead, my x will equal let's see, plugging in the value for KSP 3.9 times 10 to the power of -11. I do have a value for it. .14 times 10 to the power of -4. Let's change that so it gets it's still in the frame. Alright, so that information there. So let me copy all this again. Okay, that's odd. Anyway, that 2.14, or 2.1 because it's two significant figures, will actually be the concentration of our calcium. Now, the argument for that is primarily because our calcium ion right here would actually be X at equilibrium, and it does not react any further. Fluoride does, however, slightly with water, which I'll get into that step in a moment. In fact, this is where this problem gets, well, it'll get a little clunky once I get to the end of the next step, or next phase. But anyway, that's the first answer. We now have to set up the fluoride ion being hydrolyzed by water, which this is going to be requiring. Now, the Ka value is being described as 6.6 times 10 to the -4th. We need to use Kb because we are dealing with hydroxide at the end as a product for this equilibrium problem. And I should be using dual arrow. Alright, so I'm going to put that right here for now. So I just realized we should organize a little bit for the data because let's see, there we go. Step B. Okay. So we have this equation here, and we're going to still use the ice table. Now, before I begin that, though, so notice that fluoride is 2x, not x. So So instead, it'd be 4.28 times 10 to the power of negative 4. Now, I'm not going to answer that for fluoride just yet, even though it coincidentally is that value. But I'll give an explanation once we go through the ICE table. So right here, I have we'll go 4.3, or 4.28, yeah, let's be consistent. 10 to the power of negative 4. Alright, let's move this so that it gets a little better. Alright, then change. It's going to be a minus x right here. Oh, and we ignore water and because it's a liquid. Liquids and solids, just like with calcium fluoride and step A, we don't consider in equilibrium, because they don't affect equilibrium. Now, right here, I'm going to label off 4.28 times 10 to the power of negative 4. That would actually hold. I'm omitting the minus x for that, and for the reason for that would come to play with the Kb value. So Kb is going to be equal to 10 to the power of negative 14. And on the bottom will be my Ka value. Got a right arrow there. Kb equals fraction 10 to the power of negative 14. And this is 6.6 times 10 to the power of negative 4. Now, calculating this out, and since I already have the data presented, this will be 1.5 times 10 to the power of negative 11. That's the Kb value for the fluoride ion, and that would be used for the calculation with the equilibrium concentrations as XX and 4.28 times 10 to the negative 4th. I'll do a new equation. So for this one, I have x to the power of 2 over that 4.28 times 10 to the power of negative 4. And this will equal our 1.5 times 10 to the power of negative 11 that we found earlier. Alright. So with that, we then have to calculate our x value. So I'm going to have x squared equals the multiplication of 4.28 times 10 to the power of negative 4 times my Kb value, 1.5 times 10 to the power of negative 11. Then from there, x will equal the square root of that whole thing that I just typed in the previous step. I'm going to copy that. It's getting a little more comfortable because my back's starting to hurt a bit. So the x would equal from there. Let's see. 8.0 times 10 to the power of negative 8. So that's for that portion there. Now, so going back to here, I already established that fluorine 4.3 times 10 to the power of, that'd be negative 4 as well, molar for fluoride ion. We only use an insignificant amount of fluoride ion in step B. Though, what happens here, we will also obtain 8.0 times 10 to the power of negative 8 molar for hydrofluoric acid. Now, this is the mistake that my student made, and this is a common error in this problem because it is an oversight that is so subtle. And because usually this is not calculated in equilibrium problems. You have, since the 8.0 times 10 to the negative 8th would be classified for OH, but it was added to the solution. The thing is, this is actually below its neutral value of 1 times 10 to the negative 4th, or negative 7th, sorry. 1 times 10 to the negative 7th for that of water, neutral water. So, we actually have to add those two values. Water's equilibrium will actually come into play for that. So step C for OH negative is going to equal 1 times 10 to the power of 7, negative 7, from neutral water. And we have to add the 8.0 times 10 to the power of negative 8th. Doing so, it equals 1.8 times 10 to the power of negative 7 will be the true molarity of hydroxide. And that's not really described very much in Chem 122 or the Gen Chem 2. And last step is not too rough at all. It's a pretty quick calculation as well. Actually, I'll use the equation for that, for the last part. So display style H3O plus equals fraction, it'll be 10 to the power of, and you might have seen this before, to the negative 14th. Now you might be wondering why 14? Well, that's just arbitrarily given to it because we just saw that pattern so often. Unfortunately, there's no true rhyme or reason for it. It just so happened to be the best number that works with pH scale and pOH scale. Well, in standard conditions, that is. It gets really interesting when you go and change pressure and temperature in the room. Then neutral pH actually does change from 7. Food for thought. Anyway, now divide this out by 1.8 times 10 to the power of negative 7, right arrow, and that'll yield a 5.5 times 10 to the power of negative 8. be molar. And that's the molarity of hydronium ion. Oof. Then I'm going to be copying that. Or keeping that in my records. Yeah. Does it show that? Oh, it does show that. Don't know if I like that or not. Eh, there wasn't much information on there, I'm sure. Trying to think what I want to do, if I want to end the stream with that or not. Yeah. Yu-Gi-Oh! Tournaments. That was a phase. Not as eventful as my Smash Bros. Melee phase. That was great. I miss those tournaments. I think we all do right now, actually. Well, let's see. What else can I say? 13 views, 1 viewer currently, which is me. That's fine. I think that works. That means there's people that have been curious as to what this is, enough that they actually take a look, and well, it didn't say anything. My chat's barren. I just only have my post for the chat, which is fine. Oh, my drop frames is actually a bit less in percentage. Okay, that's a good sign. Just have to keep in mind that restriction. Let's see. Yeah, I think I'll end the stream in about a few minutes because I don't think there's many that are going to be coming out of the woodwork to ask you a question. And actually, that's a really strong one to end on. So I did a couple of Chem 121, or Gen Chem 1, Gen Chem 2. I just did a really vigorous one. Did a little bit of OChem 2, a little bit of trig, a little bit of calculus, like a single problem for each, granted. And showed a little bit of physics, was the kinematic equation. Didn't talk about rotation or projectile motion. Projectile motion is really interesting because that's when the kinematic equations, you can actually change them and manipulate them to other equations. But then you get the students that like that mentality versus the students that just want to remember the 4 equations and just manipulate those 4. Like, every student has their very own learning style, their own methods. My theory on learning styles is not the traditional 3-point that's talked about pretty often. Let's see, I believe my book has it. Where does it say? And I give myself permission to say this, obviously. Alright, so I have an insert in my book that states in learning styles. The first paragraph reads the following. Within the beginner tutor section of this journal, I mentioned the learning styles within students as follows. Sensory command, we level 1. Abstract aptitude is level 2. Imaginative imagery is level 3, and theory crafting and execution is level 4. Now, you may have actually heard about auditorial, kinesthetic, visual learners, but then if you go deeper into that, it gets really ridiculous. It gets to maybe 7 or 8 random styles that just get plastered at you. There's even one learning style of it just learned by mathematics or learned by numbers, which I see there's an argument to that, but I would label that as abstract aptitude, the level 2 that I have on here in my book. Now, the auditorial, kinesthetic, and visual, I label that off as sensory command, level 1. In fact, sensory command, I not only go for those 3, like visual, hearing, and touch, I do talk about briefly on smell and taste, on how those can actually help with your learning, especially if you're baking or cooking. Those last 2 especially are important for that, of learning how to cook and how to bake as well. And abstract aptitude is more how to mathematically conceptualize a situation. Then imaginative imagery is how to imagine the situation and how to construct what would be happening and having an idea as what phenomenon is occurring and trying to explain said phenomenon. Then there's theory crafting and execution, and that's where it kind of intermingles with the scientific method. is you come up with a theory as to why the phenomenon is occurring, and you test that theory. Of course, the thing is, usually with scientific method, you come with the theory first. Well, you do come up with a theory with the phenomenon. Actually, I haven't really read the scientific method as of late. I know that a few people have been saying it's kind of a little bit dated. I think maybe that's why I leveled it as level 4, not necessarily level 3. Because I think some textbooks make it a little convoluted, where the phenomenon is observed, then you come up with a theory. Or there's some that say you come up with a theory, then you look for phenomena. Where I think the scientific method, it's you see a phenomenon and you try to explain it using theories. That makes sense. And of course my book actually comes with that too, but not necessarily, I don't really imply that it has to be that one pathway. Theory crafting, then going into looking for a phenomenon, that's where you go into theoretical physics, where you go into omniverse theory, just imagining greater things that are beyond our scope of comprehension and existence, really. And that's where, and then quantum theory comes into play, and wacky things happen. It's all chaos. Anyway, I think that's a good stopping point. I'm just now rambling on random stuff, but that's science in a nutshell. It's just you just look for things that work, try to explain phenomenon, make sense of it all using tools. Like, for example, mathematics that we have right here, this entire session, is a tool. Math is a tool that tries to understand patterns. That's literally what it is. That's only what it is. So you take mathematics and numbers as face value? No. Never. You have to investigate where and why are those numbers and where they come from. Because math and statistics, for instance, especially statistics, is nonsense without exhaustive logic to sharpen it, to strengthen it. You can think of the math as wooden boards, maybe a few nails. Well, no, just wooden boards. We'll go with wooden boards for the mathematics. Logic, extensive logic, would be the nails, glue, and of course jigsaws saws to shape that little birdhouse you want to make. I threw a birdhouse out just as an example for the metaphor. But enough of my philosophical nonsense. Just keep thinking, and you guys want that you're studying hard as hard as you can. Keep at it. It'll be worth it in the end. I trust me. It's not just gaining that piece of paper. It's the journey. It's definitely the journey. You learn so many more things than you expect. As for me with tutoring, especially, becoming a better person, probably the all-encompassing reasoning as to what tutoring has done for me. And that's not an exhaustive list, by the way. There's many, many skills I've gained from tutoring, and many, many friendships and relationships I've forged. Anyway, I hope all of you have a great night. Let me go get something to eat, and I'll probably be on tomorrow. Have a good night.